Okay, welcome back, and we are going to finish the second part out of the three-part series on finding the number of solutions to an equation. So, I am going to begin by writing the next question down, which is 3x plus 5 is equal to x plus 2x plus 5. And again, we are going to solve these keeping in mind all the strategies that I have already told you guys about over the last couple of videos. And we're going to begin by always scanning the problem and seeing if we have any like terms that we can combine. And in fact, we do. On the right side, we have x plus 2x, which is going to give me 3x, and then we have plus 5 equals, and then we're going to bring everything down. Let the chips fall, as I say in class, 3x plus 5. So now, if you haven't already noticed something about this problem looks a little weird or different, the left side here actually is a duplicate or the same as the right side. But you could stop here, but we know both of our 8th grade math teachers, Miss Carmen and Miss Burns, like to see us work this out completely. So we're going to begin by moving the variable or isolating it to one side by performing the opposite. Okay, and when we do that, we notice actually both x's end up dropping out, which we're not used to seeing. In math, we always end up having at least one variable left, but in this case, that did not happen. So what we can see here, what we can say is that the left side is equal to the right side. And remember, if you go back up to the top, you could have also done it like this. You could have also had 3x equals 3x, or as I said in the beginning, you could have actually stopped once you noticed that you had the left side equals the right side here with 3x plus 5 equals 3x plus 5. And what this is really cool and really interesting. What this actually is this is actually what we call infinite solutions. And this is the symbol we used in class to describe infinite solutions. So why I think this is really cool? Why I think this is really cool is because no matter what I sub in when I do a check, it will always work for any rational number, meaning any whole number, any fraction, or any decimal. So if I have x equals 3, for example, I just pulled that out of thin air. It'll work for anything, but let's just check x equals 3. So I have 3x plus 5 equals x plus 2x plus 5. And again, I'm just rewriting the original equation, and I'm going to sub in the number 3 for x. Wherever I see x, I'm subbing in 3. So I have 3 times 3, which is 9, plus 5. And then I have 3 plus 2 times 3, which is 6, plus 5. And here I have 14 on the left. And when I add up all my values here, I end up with 14. So again, why this is really cool to me is because no matter what you do for checking it, you will always get a check that works, which means this equation has infinite solutions. So stay tuned to part 3 of our